once again to our lesson series in Math 103 titled Mathematics for Management and Social Science 21. Our topic for today's lesson is application of symbolic logic to physical problems. In this lesson, arguments shall be raised, translated into symbolic forms, and truth tables shall be set up to verify their validity. I hope you will enjoy this lesson as we go on. Thank you. You are welcome. Physical problems. At the end of this lesson, you shall be able to translate physical problems into symbols and to confirm their validity. This lesson is a physical application of both lesson 1 and 2. Physical problems are translated into symbolic forms. Arguments are constructed. Truth tables are set up to check the validity of the proposed argument. This part of symbolic logic is better explained using the following examples as illustrations. Consider the following example. Example 1. Given two statements, P and Q, check the validity of these connectives. Not P implies not Q, and P altogether implies Q. The table below displays the statement is valid or not. The last column contains both F and T instead of T alone, so that the statement is not valid. The last column should have contained T12 for it to be valid. You can see from the table P, Q, not P, the negation of P, not Q, the negation of Q, not P implies not Q. All these are obtained from the previous lessons 1 and 2 we had together. The implied operator and the AND operator all are combined together to obtain the last column, which contains TF, and this makes it not to be valid. The last column should have been T for it to be a valid statement or a tautology. Example 2. Construct a truth table to validate the argument below. If X is a multiple of 4, then it's a multiple of 2. X is not a multiple of 4, therefore X is not a multiple of 2. Solution. To get this solved, we assume that P stands for X is a multiple of 4 and Q stands for X a multiple of 2. Then the argument can be written symbolically as P implies Q. By similar argument as above, we check if the above connectives form a tautology. We construct a table of the form below. Also, the table is obtained from our previous lessons 1 and 2, where we have P, T, FL, Q, TL. Then you negate P and negate Q. The implication, all these are what obtained from the knowledge we had in lesson 1 and 2. And similar to the previous lesson, since the last column does not contain T, this invalidates the statements. That is, by the result of the last column of the table, which does not prove the existence of tautology, we conclude that the argument is invalid. For the statement to be valid, all the entries in the last column should be T. Example 3. Construct a truth table to check the validity of the statement below. If x is not a multiple of 6, then it is not a multiple of 12. X is a multiple of 12. X is not a multiple of 6, or it is a multiple of 3. Therefore, x is a multiple of 3. Solution. Again, as in the previous example, we assume that P stands for x is a multiple of 6, Q stands for x is a multiple of 12, and R stands for x is a multiple of 3. Then the statement can be written symbolically as not P implies not Q, and not P and R. Now you consult a truth table with 8 rows, since there are 3 variables P, Q, and R are involved. That is 2 raised to power n when n is equals to 3. That gives you 8. The table is constructed as shown. P, Q, R, the negation of P, the negation of Q, whereas where all this the letter A, B, C, and D are defined below. If it's the table is obtained from our previous knowledge, as I always say, from lesson 1 and 2, all the ideas we taught in lesson 1 and 2. Where A, as I said before, A stands for not P implies not Q, B stands for not P or R, C stands for not P implies not Q, and Q and Q and not P or R, and D is C implies R. Since the symbolic statement represented by the last column contains T values throughout, clearly this proves that the existence of tautology is achieved and the given argument is valid. Summary. In this lesson, we have been shown how symbolic logic is applicable to some physical problems. The 2 previous lessons are very useful in this 3rd lesson. This also you can apply to some economic problems as well. Conclusion: symbolic logic will be applied to get the validity of statements. They must be tautological for validity. You must always check this. You have some activities which you need to treat for proper understanding of the lesson. 1. Let P equals it is well and Q equals it is raining. Then the following statements from 1 to 8, we have to translate them into simple verbal sentence. Let P equals John is tall, Q is John is handsome. You have 2 letters there, P and Q. You have to translate each of them into symbolic form. They are already in English, simple sentence. You have to translate them into what? Symbolic form. John is tall and handsome. The word and there, the operator connected there is the and operator. So you can treat the rest as is discussed in lesson 1 and 2. Now this is another activity which you can also transform into symbolic forms. Determine like the case of if Dele is not poor, there is not a laborer. If Hassan does not study, then he will not pass the mathematics test. If he does not rain, Ngozi will wear raincoat. If David does not see clearly, then he is not a pilot. We have some references and further reasons which you can go into for further understanding of the subject. Thank you and goodbye. You're welcome.